David Smith here with one more flipped classroom math video lesson. 3 tips before we start. First, remember that you can adjust the playback speed as you desire. Second, you can pause the video at any point to jot down notes or write down questions. Third, you can turn on the captions so you can read my words on the screen. Today's topic, standard deviation and the normal distribution. And as you know, we've been working through the Is It Really Different unit out of our blue textbook, and we've mostly playing around with kind of using our intuition to figure out if a coin or a die might be unfair. Lately, we've started to quantify that difference by measuring the numeric difference away from what the expected would be and the percent difference away from what the expected would be. However, these two numbers still make it a little difficult to be a little bit more certain whether something is fair or whether it's rigged. So now we're going to start walking into a zone in this book where we're going to start quantifying the differences, and we're going to build the chi-square statistic, and then you're going to be able to say with a little bit more certainty about something like a die or a coin about which you're suspicious. Okay, so the concept here, the first concept we're going to talk about is the normal distribution. Okay, that makes a graph like this. This is called the bell-shaped curve. And you'll see that idea in a lot of places, not just mathematics. And what this means is that, well, first off, this graph, on the horizontal axis, we're plotting the value. So that might be rolling a 6, rolling a 7, rolling a 5, and then the vertical axis is the frequency. So if you roll more of one number on a die, the bar gets higher. If you roll fewer of one number, the bar is lower. So this is a frequency diagram. I'm not saying what it is that we're doing. We're just talking about it in general. So this could be a die, could be a coin, it could be a lot of things. So let's mark the average. Here is the average. So you would expect most often to get the average value. If you're, say, flipping coins a bazillion times, this would be 50 heads and 50 tails. You'd expect to get that perhaps the most. And as you get further and further away from your expected values, then you're going to get fewer and fewer occurrences of that. So you could think about it like this. If I flipped a coin 100 times, like a bazillion times, the most common value would be 50-50, 50 heads, 50 tails. As we move away in this direction, this point here might be 60 heads and 40 tails. As we move further out along the curve, it might be 70 heads and 30 tails. So we're getting those combinations of heads and tails less and less frequently. So way out here, this might be 80 heads, 20 tails. Not terribly likely. So it's going to show up less times on our frequency diagram. Okay? So the average is at the peak. And then as we get values that are further and further away from the expected value, the graph is going to fall off. The frequency is going to decrease. Okay, let's talk about 3 different shapes of the normal distribution. Okay, so here is one where most of the values are happening around the mean. So this would be a situation where when you roll that dice or flip that coin, most of the time you're getting what you would expect. And then the frequency drops off quickly as you move to the left or the right of the mean. This one, here's my mean, this one's more like that first graph I showed up. It's not quite so close to the mean, it's dropping off a little more slowly, so you're starting to see values that are away from the expecteds, more of them as you go out. Okay? This last one here, there's my average. Now my data slopes gradually away from the mean. So now on this situation, I'm getting a lot of values that are farther away from the expected than from the average than, say, perhaps this one. So why are we talking about these 3 graphs? This is a measure of how spread out the data is. Okay, so this data is not very spread out at all. We're doing a situation and we're getting most of our values are right at the expected values. This situation, the data is a little bit more spread out. Finally, this situation, the data is very spread out. So even though there is an average, it doesn't characterize the data all that well because it's very possible to get values that aren't in the average, okay? Whereas this situation, data is not spread out at all. You do this experiment, you're most likely gonna get the expected value. Okay, so standard deviation, by the way, here's a new Greek letter. That's the lowercase sigma. It's kind of like an O with a line shooting off to the right. This is sigma, and it equals the standard deviation. So standard deviation is a measure of how spread out the data really is. So in this one, you're going to have a relatively small standard deviation. In this one, the standard deviation is getting bigger. And then finally, in this one, the data is very spread out, so your standard deviation would be fairly high. One last point before we move on to this graph. Normal distributions occur with situations that are fair. So if you roll a die, flip a coin, all those kinds of things, you graph that data, you should get a normal distribution. So we can use the normal distribution to evaluate situations to try to figure out if they are indeed fair or not. Okay, so let's take a look. Here is my normal distribution. I marked my average. It goes right through the peak. Now what I did is I have these 4 extra vertical lines. One set going this way, one set going that way. And what I've done here is I've marked off a standard deviation. I'm using sigma. So for different situations, that standard deviation is going to be a different number, but it is there. Okay? So, and then this is also one standard deviation. Okay? And then this here is a second standard deviation. And that one here is also a second. So whatever the value of the standard deviation, we can move 1 standard deviation away from the mean, and we can move 2 standard deviations away from the mean. Now here's the cool thing about that, is that this distance here, 1 standard deviation either way from the mean, this is going to be 68% of the data. So if you have a normal distribution, like you're flipping a fair coin, then 68% of the data that you collect is going to be within 1 standard deviation from the mean. And then similarly, in another way, 95% of the standard deviation of data, So 95% of your data is going to be within 2 standard deviations of the mean. Okay? So if you flip a coin 100 times and you get a certain number of heads, and you look on your graph and that number of heads is way over here, you're well beyond 2 standard deviations from the mean. So you're not in this 95% of the data, so you're naturally going to be more suspicious about that coin not being a fair coin. Okay, I thought I'd do a question using the concepts of standard deviation and normal distribution. And typically students find this a little bit challenging, especially with some of the first problems out of our book, because you have to pull all this information together, it's a little complicated, and then use it to answer a very specific question. Okay, here's our question. Ant Killer, it's a brand of ant spray, claims to be better than Raid ant spray, which has been tested in many trials. So what that means is that Raid has been tested over and over and over again in a whole bunch of trials. They gathered a bunch of data, and then implicit in this question is that that data, the Raid data, follows a normal distribution. Okay, so that we need that to answer questions using standard deviation. Okay, so Ant Killer says it's better than Raid. And the nice thing is that Raid has all these trials that we can use to evaluate Ant Killer with. So here are the data from the trials. Using Raid, the average number of ants left is 220. We're assuming that there's some big population, they sprayed it, and the average number left is 220, and they tell us the standard deviation is 38. Okay? So we have this big pile of pre-existing data. Now what we're going to do is one test of ant killer. We're not going to do a million tests, just one test of ant killer left only 105 ants. So it's at least suggestive that ant killer is better than raid, but we need to take a little bit more of a close look with that to be definitive. And here's the question, is it better? Okay, so to answer that, the first thing we need to do is put up the normal distribution and mark off the standard deviations for raid. And I've got to start here. I've drawn my frequency diagram, frequency on the vertical axis, the values on the horizontal, and this is ants left using raid. And I marked off our average, 220. That's from here. Average number left is 220. And that corresponds with the peak. That's the mean. That's the most occurring value in our normal distribution. And now we need to mark off our standard deviations. So let's do that. It goes on both sides of the mean. And that distance there is 1 sigma. Okay? So that's 1 away. That's 2 away. This one is also 1 away, and that one's 2 away. Okay? We're getting close. We need to mark off our values. So if standard deviation is 38, and we're at 220, this is going to be 182 there. That's 220 minus 38. And then this will be 144 here. Going the other way, this is 258, and this is 296. Okay? So now we know where these standard deviations are on our graph. So we've marked it off. This is very numeric. Remember the last little slide, we just showed you what it was. Now I've got this real situation comparing ant killers, and I've got this data on raid. Okay, so we know how this product performs. What we need to be able to say is, based on one test of ant killer, is it better than raid or not? And we can't be 100% certain in our answer, but we can get close. So let's take a look. One test of ant killer left 105 ants. Okay, so that's like probably down here, right? Let's take a look at 220 minus 105. That's going to be 115, right? So that's how far away it's from the mean. I just used the mean for raid, and I subtracted out 105 to find the difference. This is how far this data point is away from the mean, okay? Now that's over 3 standard deviations away. So you're probably starting to feel maybe like, yeah, this is better. But let's get really specific about that. Okay, so remember those percents that we talked about before? This is 68% of the data in a normal distribution is 1 standard deviation away from the mean. So that means 2/3 of the data is going to be within 1 standard deviation. This one was 95. Okay, so 95% of the data has to be within 2 standard deviations of the mean. Now, with ant killer here, we are more than 3 standard deviations away. So you can't explain ant killer's performance as a variation on this performance. We're just too far away from the mean for this data. So what this tells us is that ant killer is very likely better than this product, than raid. Okay? On the flip side, if ant killer left, let's say they left 200 instead of 220, at first you might think, yeah, that's better. That's good. Well, 200 is great. It's better than ant killer. That's 20 more ants not jumping in my house. However, 220 is right in there. So that number could very easily be explained by sampling fluctuation in the raid data. So even though it is less, it's way too close. It's way too close to the mean. It's within 1 standard deviation that we can't really explain that as being different than raid. Maybe the next trial we did with ant killer would be 20 on the other side. But 105 is far enough away from the mean. It's over 3 standard deviations from the mean. So that means it's really hard to explain this product using this graph. It suggests strongly that this product really is different than this one. Now that you've watched the video, take a moment to jot down additional notes, some questions for class, or a short summary of the lesson. You can also go back and re-watch the portions of the video that were a little bit challenging for you. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.